Hello, everyone. Thank you for joining today's webinars. My name is Chinh Nguyen. I'm application leader of the domain Microfluidic. So today we will talk about a microfluidic fabrication, Monodisperse polymeric microsphere for biomedical application. So let us know by write down your question in a question box or chat box, and then we can have further discussion in Q&A section. So the content of the presentation today will be including the introduction, and then we move to the introduction about the dolomite microfluidic system, and the finals will be talk about the microfluidic fabrication methods for making of monodisperse polymeric microspheres. So actually, the dolomite is a part of the black trade group, and we are driven by productizing science. So it's turning scientific discoveries into cutting-edge commercial product. We develop, design, and sell the market leading product through our global leading brand, which includes dolomite microfluidics that develop most of innovative and advanced product for microfluidic application that offering a range of modular system and components. And the particle work provide game-changing particle generation platform which allow you to produce nanoparticles with unrivaled precision, quality, and consistency of control while reducing your development time and cost. And Dolomite Bio will provide solution for high throughput single cell research sequencing. The Dolomite overview, so we provide in both of the microfluidic complete microfluidic system, that's including the micro droplet system or double emulsion system or nanoparticle synthesis, and also microfluidic components that individual modular accessory, including the microfluidic chip, microfluidic connectors, pump, sensor, and the other components that can help you to build up the microfluidic system. We also provide custom solution to customer to design to the customer requirement. For example, like design fabrication of the glass microfluidic chip or connector, pump, sensor, or any of microfluidic instruments. The dolomite application team, we have a team of the chemists and engineers that will focus to produce high performance nanoparticles and microparticles with precision control over size, shape, and structure by using microfluidic and flow chemistry. So we focus on biomedicals and pharmaceutical industry. We supply standard products, for example, like emulsion stabilizer or surfactants. And also we advise the customers on microfluidic setup and processes. And if required, we can undertake proof of principle projects like feasibility tests for our customers before equipment purchase. So how does the microfluidics work? If you have a look at the left-hand side, so it is the conventional homogenizer technique, or we can call it the traditional batch method for making emulsion. So most of the emulsification process work through input energy into two immiscible liquids. So with the batch methods, normally the high input energies will be applied, and the larger volume of reagent will be required with the poor size distribution, with the variable reaction condition, and it had challenging to scale. However, with microfluidic methods, so the droplets are pinched up with the minimal input energy through the chip junction to make the droplet or emulsion. So using this, we can provide with tiny reaction volume are feasible with minimal waste and with excellent size distribution due to the parameters that can affect the process very easy to control, like flow rate, X fluid, or temperature, or concentration of the H component. And it also providing consistent process condition due to reduce the flow, the chemical flow process, and it can be scalable by numbering up easily with the minimal input of energy used. We have many ways to make up the droplets or particles by using microfluidic method. We can make up the slug with size larger than junction size using the T junction chip here, or we can make up single emulsion by the X junction chip, or we can make up the more complex emulsion like double emulsion or multiple emulsion like droplet in droplet, or we can do with the cell encapsulation that can placing one or number of shell particles inside the droplet, or we can do the nanocrystallization by mixing of two streams and subsequent isolation of the reagent into the droplets. So in this case, the droplet can have a role as a microreactor that the reaction can be occurs inside within the droplet. Or we can do the more complex particle like Zynet particles. So by just introducing in complex mixing of the two streams of forming particle with the heterogeneous surface properties. So there's two ways to make the particle with different size in micro size and nano size by using microfluidic. So for microparticle formulation, we use the droplet forming method. So thus we make the emulsion or droplets by introducing two immiscible liquid into the tip junction, and then the particle can be formed by using another methods, various methods like chemical or rapid mixing or solvent extraction or thermal treatment or UV polymerization or chemical cross-linking or nano precipitation. So this method basically can generate a particle or droplet with the size from the, more than 1 micrometer to millimeter of size. And for nano size particles, we use flow focusing methods. That means we introduce two miscible stream, two fluids, immiscible fluids into the microfluidic chip to make up the flow focus stream. And the nanoparticle we believe to generate at the interface of the two streams and flushing out by the continuous flow process. So with a range of microfluidic junction size and geometry, we can do the formation of the wide range of the emulsion and particles. Here is all of the example of chips that we have made with different geometries and channel size in order to make particles of the wide range of size and material over the past of 15 years. So all the chips are made in-house in our clean room facilities, and we frequently manufacture custom design chip for specific customer application. One of the examples of microsphere that used into the biomedical application is a PLGA particle. So it is polylactic glycolic acid, and it is one of the most successfully developed biodegradable polymers that used as drug delivery system, and it approved by FDA and EMA. So with current method, the PLGA synthesis rely on batch type homogenizer that typically is the results in a wide poly particle size distribution, which is not attractive for pharmaceutical application. So using the microfluidic method for making of the PLGA microsphere, so it brings many advantages, like it can enhanced control over extent of particle fabrication process with the great particle yield and nano size distribution, which is small average size and easy scale up. We can use PLGA's microparticle to encapsulate the API or other maker inside for drug encapsulation. So it's wide use for microencapsulation and control release of the API protein or antigens. With the traditional method, using for hydrophilic drug loading, it means aquasoluble drug loading is poor. It means that's very low drug loading inside the microparticle PLGA microparticle by using the traditional method. Also, with the traditional method can produce very polydispersed particles which hindered accurate drug release. Using the micro methods, it enables to achieve with high drug encapsulation efficiency, with high monodispersity, that we can have further discussion in next slide in this presentation. The next section, I would like to introduce about the Dolomite microfluidic system. So here is the three main type the microfluidic modular system that Dolomite provides. We have single channel system that's used to in lab scale or IND scale. That could be a particle generation systems like lipid or PLGA or alginate or hydrogel particles generation system. Or it could be the single and double emulsion system or porous media system and educational system for the education about the microfluidic. The second system is the microencapsulator system. It's a single cell encapsulation system. And for scale-up system, we have tailored scale-up system that is high throughput system for droplet of particles generation and encapsulation. This is more detail about the single channel system. Basically, it has composed by 3 pressure driven pumps that can provide very smooth flow fluids to before going to the microfluidic chip by control the fluids by control the pressure. So the pressure pump will be connected with the microfluidic chip by connector and the tubing, and the microfluidic chip is located under the microscope that integrate with the high-speed camera that can help customers easy to visualize all the process of droplet formulation that happen inside the microfluidic chip junction. So with the design, keep in mind design that the system design in very flexible with the flexible option, and the system is kind of modular system. So it means that the customer can use the one system to do the wiring of the application with the small or minor strings by using the different microfluidic chip geometry, or by add or remove more component into the system. The microencapsulator system is a complete system for high throughput encapsulation of individual cell into picoliter droplets. So it can work with a small sample, 100 microliter or less than 100 microliter. It can encapsulation of single cell or DNA or the other material, and it can encapsulate 300,000 cells within just only 15 minutes. And it has second channel that allow to do the core encapsulation with a functionalized with and reaction measure like the hydrogel material like acryl or the alginate. And it's idea for profiling natively paired TCR or isolating antibody coding sequences, and encapsulating cell in hydrogel or encapsulating expression libraries for fast sorting. And the tailored scale system, it can increase the throughput by 3 distinct ways. it can increase the flow rate through the individual junction, or it can increase number of junction working in parallel. So basically, with the single channel chip, we have one single channel in one chip. But with the Taylor chip, we can integrate up to 7 channels that working in parallel in one chip. And the throughput of the Taylor system can also increase by increased number of chips working in parallels. So by the Taylor, using the Taylor's modular system, so we can run up to 10 Taylor chip running in parallel together in one system. So it means that the system can run up to 70 single channel junction in one in parallel in one time. So it means it can increase throughput up to 70 times compared to single channel system. And we move to the section that focus more in case study with the microfluidic fabrications method for making a monodisperse polymeric microsphere. The first example, I would like to show the method for making of the one common polymers that using that's commonly used in biomedicals. So it's a PLGA microparticle production using the microfluidic method. So with this method, the PLGA is dissolved into an organic solvent with low water miscibility. So for example, we dissolve the PLGA in DCM, and then we introduce the PLGA and DCM into the antisolvent like water. So droplets will form at the microfluidic junction, and then droplet size can be controlled by just selecting a junction site, different junction site, like larger junction chip can generate larger droplet size, or small junction chip can generate a small droplet size. Or we can control droplet size by adjusting a relative flow rate of continuous and droplet phase. So by just changing the relative flow rate of droplet phase and continuous phase, we can change the droplet size as well. And then the PLGA solid monodisperse particles will be occurs as the result of the solvent evaporation. Here is a system setup for making a PLGAs by using our single channel system. So we have 3 pumps set up. First pump for delivering of the carrier phase like water, and using the PBA as polyvinyl alcohol as surfactant or emulsion stabilizer. And the second pump will be used for driving the droplet phase like PLGA in DCM. And the third pump can be used for flushing phase, for example, like only DCM for cleaning the system before and after running experiment. So the droplet junction chip 100 micrometer will be used in here, and the PLGA DCM droplets that disperse water will be generated at the junction chip and go to the collection wire for collection. And here is showing the droplet formation just visualized under microscope that happen inside the drop junction. And the PL solvent extraction process is showing in this video. So this video showing the droplet after formulation that contain DCM and PLGA inside that have a size of the 84 micrometer. So during the time, the DCM will be extracted out to the droplets and into the water, and then it will leave the solid of PLGA with a final diameter of around 24 micrometer. So the solvent extraction process can be happen very quickly. Just only 5 minutes we can obtain the solid solid PLGA microparticle from a droplet. And we can encapsulate the API into the PLGA for drug delivery. So Microfluidic can be used to encapsulate the API into the PLGA microparticles by just encapsulate the API into the PLGA droplets by Microfluidic, and then leaving with the traditional solvent extraction, and the result will be the API encapsulated in PLGA solid microparticles. So there's two types of the APIs that can be encapsulated in PLGA bit. Firstly, it is hydrophobic API, or hydrophobic the encapsulant or maker. So in this case, the API is dissolved in organic phase like PLGA and DCM mixture. And then we make a droplet using a Microfluidic protocol in a Microfluidic chip. And the solvents are extracted by the extraction into excess water, that's followed by evaporation. With the solvent extraction process at laboratory scale, a simple overnight extraction is sufficient. And at the production scale, continuous flow extraction is required. So it extracts both sides range of the particle from 1 to 30 micrometer by using this method, and the encapsulation efficiency is nearly quantitative. In terms of the hydrophilic API, it is aqueous soluble drug or API can be encapsulated in PLGA by first dissolving the drug in water and creating a multiple emulsion. So we use two chips with this formulation. So the API, the firstly pre-dissolved in aqueous medium, and then primary emulsion water in PLGA DCM that will be obtained by within chip 1, and then the secondary emulsion of PLGA in DCM in water will be formed by within the chip 2. So the multiple emulsion will go through a standard drying process to leave water droplet in PLGA matrix. So after drying, the water droplets are retained in the hardness the PLGA microsphere. The encapsulation efficiency by using this method is from 50 to 80%. Here, showing some examples that we have done in lab with using the 2 micrometer water droplet contain API inside of 20 micrometer of PLGA droplet, and it immediately after droplet production in using the 3D pore chip, and then after solvent extraction and drying, so we obtain around 15 micrometer of PLGA particle that contain the water droplet with API inside. Here, the system design for multiple emulsion production. So we use a 3 pump and maybe 1 more pump for washing fluids or washing process. And so we use 2 chips in this case. The first chip, so 1 pump we connect as droplet phase, like water with drug. Here goes the first chip, and the other pump will be used for the carrier phase, like polymer and solvent, like PLGA and DCM. In here to make of the water droplet in PLGA continuous phase, and then the product of the first chip will be used as the feed droplet phase of the second chip. So with this in second chip design, so we use the third pump for chip 2 carrier phase, like water with the surfactant like PBA. And finally, after pass through the second chip, the water in PLGA in water multiple emulsion can be obtained. in the second as a final product. And the other method for encapsulating of the hydrophilic of API of drug is we use the powder encapsulation. So in this case, one chip is used typically with 100 micrometer chip junction, and API is suspended through the PLGA and DCM mixture to make a suspension that contain a PLGA, API, and DCM. And the emulsion will go after the pass through the chip junction, and then it will go through a standard drying process to leave the API powder distributed through the PLGA bed. So with this method, the typically encapsulation efficiency we can obtain is 60 to 95%. In here is some images showing the very high monodisperse of the drug or APIs that encapsulate into the PLGA's microsphere after drying step. Other case studies. In here, with using system, we also can using Microfluidic method we can use for a hydrogel-based production. So the hydrogel is manufactured by both of the chemical gelation or thermosetting. With chemical gelation, so two reagents combine and they are pinched up at the junction, and gelation will occur in flow or in the collection vessel by means of introduction of third component. And in this case, the payload is typically brought in on one or both of the aqueous slide. For the thermosetting method, so the materials is taken above 0 point like agarose, and it's pinned up at the temperature control junction and collect and setting through the cooling. Then in this case, the payload can be brought in on a hot or cold aqueous slide. So here example for making agro and alginate beads by using our Microfluidic chip. So this one showing the agro beads we produce with the dolomite 3D flow focusing chip. So by the thermal treating process. So in this case, agro will be heating over the melting point temperature and pass through the chip junction to make up the droplet, and then pulling the droplet to generate hydrogel bead. And the second image you can see in here showing the sodium alginate bead produced with the dolomite 2 reagent chip. So in this case, we're using the chemical treatment process. So the two reagent of the agro alginate with the other chemical will be introduced into the Microfluidic chip and then generate at the drop junction chip to generate droplet that contain alginate and the other the reagent, and finally the reaction will occur inside the droplet and generate of the hydrogels of alginate. The polymer bead also can be manufactured by undertaking cross-linking reaction on the performance droplet. So we can use the polymerization. We can use the different method for initiating of the polymerization or cross-linking reaction. So for example, like we can use UV initiator or thermal initiator or chemical agent. So the polymerization can be undertaken in continuous flow or after collection using this method. For scale from the lab to production, in here is an example that our customer use our Taylor system for making the PLGA particles. So let's say if we want to make 1 ton per month of production, so it means that we need to run at 100 milliliter per minute in a 5 days per week, or we will need to run 25 milliliter per minute with 8-hour day at 24/7. So in this case, our customer to do will do the PLGA particle production using the 5 tera chip and running at the 12.5 milliliter per minute. So it means that they can do with the production rate up to half ton per month using with the 5 tera chip. This showing the video showing the process that at the side of the our customer using the tera system. So in here we use the pressure pump and extended the sample reservoir to contain the more sample and introduce into the tellers. This one the tellers. Process running with the 5 teller chip. And we also can provide the customer the custom pressure chamber that allows to run with the higher volume of the system, high volume of reagent, sorry. And with this, it's showing the how to collect the sample after production, and it shows that the production rate is very fast process. So this one showing the emulsion of the PLGA and DCM that water before the drying process. So as you can see, we can see the 2 layers that we have. One, the bottom layers is the PLGAs and DCM droplets, and the upper layers is the water and surfactant. So with the Taylor system, we can we have a modular system with up to 70 trainers that can run at a time together, and many possible configuration and particle format is available. For example, like double emulsion. And we can also add the real-time QC and GMP capability into the system if required. Here showing the throughput accessible today. So with the single channel system, we can use in the large scale or any scale that can commonly generate from 10 to 30 grams per day. So for scale up, the customer can use the Taylor system that can be generate 1 to 3 kilogram per day. And if we can integrate the Taylor system with the micro mixing chip, so we can increase up more in throughput, like from 10 to 30 kilogram per day. So it means around 1 ton per month in production rate. So as I mentioned that our system is very flexible. So with a system, we can make many different type the particle. For example, we can do it alginate, we can do the agro or the other polymeric bed like PLGA or PEG or platinum dot, or even with the nanoparticle within the minor change in system setup. For example, like we need to change the chip geometry, chip type, or with the flow rate range different to adapt the specific application. So summary, dolomite can target many key applications in area of PLGA and another microsphere particles. For example, like polymeric microparticle like PLGA particle, or hydro microparticle, for example, like agro or alginate microparticle for controlled drug encapsulation. Also, dolomite processes can be scaled to pilot plant production level using our multiple modular Taylor system. Okay, so before finish my our presentation today, I would like to just have a quick note to honor to you that we are still calling for submission for Dolomite Microfluidic competition. So you win the Dolomite product up to $6,000 in value, and you can submit by just preparing a sort of proposal and introduction video about your project. And the deadline for competition is November 30. So please visit our website for more information, dolomitemicrofluidic.com. So thank you for listening our presentation. So now we are moving to a Q&A section. If you have any question, please write down your question in the question box, and we can have further discussion in this section. Otherwise, you also can email to our Hanoi office at blindcheck.com for further or later question or discussion. Thank you. Let me check the question out. Okay, I have a list of questions recently. The first question is, can you generate a irregular control shape of polymer by changing the slide? Okay, it's a good question. Actually, basically with microfluidic methods, we can control the shape of the droplet in sphere shape, in sphere formation. So for other shape type of the shape polymer particle, it's a little bit hard to obtain. Otherwise, you will need to study about how to generate the particle by after formulation of droplet formation. For example, like using different material with during the evaporation process or other specific methods. But anyway, with the microfluidic method, commonly we use to make up the microsphere of particle, not by other random or other the specific shape of the polymers. The second question is it possible to generate microparticles of any polymer? My answer is yes. In terms, if you can find the way how to dissolve the polymers into the solvent, like you can choose with different solvent to dissolve the polymer and make a droplet or make emulsion of the polymer inside the solvent in an anti-solvent like immiscible solvent, immiscible fluid. So you can make up the microparticle that kind of polymers. Otherwise, you can use the method for making particle like making a chemical reaction within a droplet. So you can mix different chemical within, including the precursor, the polymer precursors, and also another initiator or reagent to make up the polymerization or shrinking process within a droplet, so you can generate microparticle. Thank you. So next question is, which system do you use to check the size quality of final encapsulate? Okay, so basically in microparticle size, we use microscope that's providing along with our system to check the size quality. We have a advanced FTC flow controls software that can inline analysis of the droplet at the formulation, or we use the analysis software, particle analysis, images analysis software to analyze the quality of size and the step of the final encapsulate. Sorry. Otherwise, you can use another method to quantity or to analyze the size of the particle, for example, like SEM or another spectroscopy method to do that. Okay, so next question is, don't you have a basic recipe to create a capsule when you use your equipment? Okay, so we have a list of the application notes that use for our common polymers particle generation or hydrogel particle generation using our system. For example, like we have application note or protocol for making a PLGA microparticle. We have application note for like packing the microparticle or alginate or agro microparticle for the material. So it will require to customer to study with the system. So we just provide kind of the standard product, just use our system. Okay, hope it helps. I have one more question is, what about the idea of API inside capsule? Okay, it's also a very good question. So normally the API, if the API can be dissolved into the solvent or in water, and that we use for the hydrophobic API encapsulation or the multiple emulsion encapsulation. So there's no require for the idea of the API. Otherwise, if you use the powder encapsulation, so my experience that we should use the fine powder with if you want to encapsulate inside of the particle with the size of around 100 micrometer, let's say, using the 100 micrometer of the drop junction chip. So it will require to use less than 10 micrometer of the API, and then it can have to make up the good suspension before introducing into the microfluidic chip. So also the finer powders of APIs will help you to prevent any blocking that can happen during passing through the microfluidic chip junction. Also, it can preventing the dense particles that are caused by different density or gravities of the API with the solvent or polymer. So I think it's better to make sure that the API had the fine or monodisperse in terms of size, and it has as small as size possible. Let's say less than 6 micrometer or some value around 6 to 10 micrometer. So that is okay. How do you check the ID? Okay. Just checking the IDs that by using filtration, or you have to measure the IDs the API by the other analysis method like SEM or microscope, not using the optical microscope to see what the size of the API, what the size of the API. Or otherwise, you can remove the ladder of the ID particle by just using the filtration before running the experiment with the suspension. I hope this helps. Okay, is there any question? Okay, I got one more question. Okay. So how will be the distribution of the hydrophobic drug in microparticle? Will it require the sonication to get uniform distribution? Okay, it's also a good question. I suppose that you will use the powder encapsulation method for the hydrophobic API encapsulation in microparticle. So basically, for making a suspension, we can use sonication. Yes, we can use sonication, or we can use stirring to make sure that the oil of the drug, hydrophobic drug, can be well dispersed in the solvent to make a very good suspension before introducing to the microparticle to the drop junction. So if you make a good suspension, so the distribution of the API in microparticles will be very monodisperse, homogeneous, because we pumping and delivering the API, the drug, hydrophobic drug, and PLGA and solvent together, and go to pass to the drop that is to make a drop that contain of PLGA, the API, the drug, and the solvent. So after solvent extraction, it will leave the PLGA and the drug inside. So our test showing that with method we can generate very homogeneous of the API inside particles. I hope this helped. So if you don't have any question more, I would like to thank you for the honor attention. And if possible, please spare a minute with us to let us know how we do today. Thank you very much, and hope to see you again in our upcoming webinars that we will notice in our website. Thank you very much.